ASP.NET WebForms was introduced as part of the NET Framework 1.0. It was a monumental shift from ASP Classic, introducing a new paradigm for building web applications that mirrored the event-driven model used in desktop application development. Microsoft designed WebForms to simplify web development and make it accessible to a broader audience, including developers transitioning from Windows Forms or desktop applications. WebForms introduced an event-driven approach similar to desktop applications. Developers could attach server-side event handlers to UI elements like button click or text box text changed. This abstraction allowed developers to focus on application logic without worrying about the underlying HTTP protocol. WebForms provided a rich set of server-side controls such as text box, button, and grid view. These controls encapsulated complex functionality like rendering HTML, managing user input, and maintaining state across requests. Controls like allowed developers to bind and display data with minimal effort, offering features like sorting and paging out of the box. View state is a mechanism for preserving the state of server controls between HTTP requests. State data is serialized and stored in a hidden field within the page, known as. This simplified state management for controls without requiring explicit coding. However, it increased page size due to view state data, impacting performance and debugging issues related to view state corruption or bloat. The page lifecycle in WebForms was a structured sequence of events, enabling developers to plug into different stages of processing. First, there was the page request, which checked if the page was in the cache or needed to be re-rendered. Next came page initialization, where properties of server controls were set. Then, load view state restored the state of controls from view state. After that, page load executed the core logic, including data binding. Postback event handling followed, managing events triggered by user interactions like button clicks. Rendering converted server controls into HTML for the client. Finally, unload cleaned up resources. The lifecycle was powerful but added complexity, especially for new developers. WebForms separated the presentation layer, or HTML, from the logic layer, which was written in C# or VB.NET, using a code behind file. This approach encouraged cleaner code organization and made the application easier to maintain and debug. However, the tight coupling between the UI and server-side logic led to challenges in unit testing and scalability. WebForms relied heavily on postbacks, where the entire page would be sent to the server and re-rendered in response to user actions. This simplified the development of interactive features like form submissions and event handling, but resulted in poor performance and user experience due to the need to reload the entire page. WebForms introduced data binding capabilities through controls like grid view, repeater, and data list. Developers could bind these controls to data sources, for example, SQL databases or XML, using minimal code. This abstraction simplified crude operations, but, it limited fine-grained control over HTML rendering. Introduced with later versions of WebForms, master pages allowed developers to define a consistent layout, such as header, footer, and navigation, for multiple pages. Child pages inherited the structure and could insert content into predefined placeholders. WebForms provided built-in authentication and authorization mechanisms, such as ASP.NET Forms, authentication and Windows authentication for user management. Role-based security allowed developers to restrict access to specific pages or features. Additionally, server-side and client-side validation controls, for example, required field validator and range validator, helped prevent common input-related vulnerabilities like SQL injection. WebForms applications were compiled into DLL files, which, improved performance compared to the old interpreted ASP Classic code. Deployment was pretty straightforward, as developers only needed to upload the compiled files and configurations to the server. The reliance on postbacks and view state bloated the page size and slowed down performance, especially over slow network connections. Applications built with WebForms struggled with scalability under high traffic due to these inefficiencies. WebForms abstracted the underlying HTML and HTTP, making it difficult for developers to produce semantic, clean HTML. Customizing the rendered output was cumbersome and often required workarounds. The code behind model tightly coupled UI and server-side logic, making applications difficult to test and maintain. Reusability of components across projects was limited. WebForms was designed for a server-rendered monolithic architecture, making it ill-suited for the rise of SPAs or single-page applications and RESTful APIs. WebForms enabled developers to build complex, data-driven web applications quickly using pre-built server controls. This appealed to enterprises looking to modernize their applications without requiring deep knowledge of HTML or JavaScript. The event-driven programming model closely resembled Windows Forms, making it easier for desktop developers to transition to web development. Enterprises favored WebForms for its ease of use, built-in security features, and integration with Microsoft's ecosystem like SQL Server and IIS. WebForms became the de facto standard for enterprise web applications in the early 2000s. It significantly lowered the barrier to entry for web development, enabling a wave of developers to create dynamic, data-driven applications. The limitations of WebForms, particularly its abstraction of HTML and performance bottlenecks, prompted Microsoft to rethink its approach. Developers wanted more control over HTML rendering, better scalability, and adherence to modern web practices like REST and AJAX. This led to the development of ASP.NET MVC, which emphasized separation of concerns, clean HTML, and a stateless architecture. Let me know if you're ready for an in-depth explanation of ASP.